Have you ever wondered what makes different decks in trading card games unique? In every TCG, decks can often be grouped into archetypes based on their playstyles and strategies. You might have even heard the term combo, aggro, control, or mid-range, and while those archetypes feel correct to people who play card games, there are after all long-standing Magic the Gathering deck archetype charts. Let's try to actually take a look at what the data says for our card game of choice, the Digimon trading card game. But first, let's try to actually describe why archetypes matter in the first place. In some ways, knowing the archetype of a deck can help you choose the right deck for your playstyle, and then it can help you choose and pick the right traits you want for the deck you're building. Not to mention that it also helps communicate to other players the playstyle of a specific deck. And on a more abstract level, it can help compare different TCGs to each other by highlighting what features are most important in that TCG. So now that we have the why, let's look at the how. Because the Digimon TCG is smaller than the big three, it's easy for language surrounding archetypes to be based off the playstyles of other TCGs, such as the aforementioned Magic the Gathering archetype charts. And while this video could be about placing decks from the Digimon TCG into the archetype graph, I wanted to focus more on the process of establishing those archetypes, and maybe looking at decks in a new way that can be applied to other TCGs as well. And despite Digimon having its particular way of playing the game that is very different from other trading card games, what with the memory gauge and inherited effects, letting you create the monster of your dreams, I think that this process can definitely be applied to, or be the inspiration for, other ways to look at archetypes in trading card games. So let's describe the process. First, what I did is I raked my brain for every single deck I could think of going up against in the last year, to just filter out any really old decks and things that aren't really relevant to the current design philosophy of the game. It is worth mentioning that only decks up to EX6 are included since this video took a long time to make, but the process can apply to any set moving forward. From this, I ended up with 53 decks. I then took those decks and then rated them on a scale of D to S rank across 7 different categories. It doesn't actually matter how many categories I came up with, or that they might overlap. As you will see, that's actually kind of the point. What matters is that I found abstract ways in which decks are different from each other. With that disclaimer out of the way, let's describe the categories. The first one is speed. And this just means on average, how fast can the deck reach its win condition. The second category is memory/card efficiency, and this just refers to how many resources can each action in the deck generate. I've also heard this referred to as fairness, but I find that term to be a little ambiguous. The third category I came up with is called influenceability, and this would just refer to how much of the deck's performance is affected by the opponent's game plan, i.e. how influenceable is your own deck's game plan by your opponent's game plan. This is one of the definitions of interactivity I came up with. Security control, a deck whose only purpose is to stall realistically, is therefore highly dependent on opponents' game plans, and by this definition is therefore highly influenceable. Alter S, for example, is a deck that doesn't care about your opponent's game plan and just does its own thing, and therefore would rank low on influenceability. The next category is something a little bit more familiar, which is just linearity. And linearity here is just how consistent is the game plan from game to game, which would be a synonym of consistency. The next category after that is just board presence, which is trying to describe how often are creatures on board. The quantity itself doesn't actually matter yet. One thing to keep in mind here is the Digimon TCG's breeding/raising area, which is an uninteractable area where effects can't be triggered either. Decks that mostly stay in the raising area do not count towards having board presence at this time. This is then followed by board wideness, which is now how many creatures, and to a certain extent other less interactable card types like tamers, are on board on average. And finally, stickiness. This is just how difficult it is on average to remove the creatures from this deck from the board by having things like protection effects, floating effects, or even resurrection effects. To reiterate, decks can be scored from D to S in any and all of these categories. So let's try to actually score a deck really quickly. And let's pick something that's always on people's mind when trying to build a competitive deck, Magna X. And more specifically, the vaccine version. The goal of this deck is to build a stack with the best protection effect in the game so far, aside from Mother D, but that's an edge case. This stack then just tries to win the game by attacking your opponent and having your opponent not being able to respond due to the protection effects. One of the reasons it's good right now is because it's actually quite fast, so we'll put the speed to A. For memory and card efficiency, I give this deck an S rank, since the Patamon TK Emissary of Hope combo generates so much value. Influenceability, therefore, from the definition of the deck that I gave before, is a D, since the opponent is not intended to interact with the stack due to the protection effects. Obviously, the deck then gets a score of A in linearity since the game plan is the same from game to game. Board presence is gonna have to be an S tier. Once Magna X or Rapid X is on board, they're some of the hardest bodies to get rid of. Board wideness is a C in this case since the deck's goal isn't to try to build multiple stacks ideally. It would like to just stick to one if it can, but it's not uncommon to go against the deck and have them have more than one stack. And finally, stickiness. Due to the aforementioned protection effects, comboed with the layers of armor purge that this deck has, it becomes very sticky, so I'm going to put it to S. And now we have our final rating. It's important to note here that this does not need to be exact for the technique that I'm going to describe to work. As long as it's approximately correct, we're going to be fine. So after scoring all 53 decks by hand, and after asking around and playing the decks myself, let's see if any of these traits correlate with each other. What this means is that we're trying to see if some of these traits can explain each other or can be considered redundant, mathematically speaking. The word for that is covariance, and I won't bore anyone with the details, but essentially I did this by making what's called a covariance matrix. All the numbers you're seeing here reflect the strength of the correlation between each trait. Let's erase the redundant ones and highlight the magnitude of each value. Anything in red means a strong positive correlation, and anything in blue means a strong negative correlation, relatively speaking. We're now ready to do something called PCA, or Principal Component Analysis. So to do that, we have to rewind a bit. We currently have 7 categories. 7 categories is not exactly easy to graph, and not to mention that we haven't addressed the fact that some of these categories kind of overlap with each other. One thing we could do is try to find the 3 most important traits, but then we're also losing the information from the other categories. Instead, what PCA does is try to combine all the categories together into 3 distinct traits. The downside of this approach is that we won't know what those 3 traits represent until we try to interpret the data ourselves. So for now, we'll call those 3 traits PC1, PC2, and PC3 for Principal Component 1, 2, and 3. Another thing that PCA does that's really nice for us is that it ranks the outputs by importance, which means that PC1 represents the most important trait that decks can have, followed by PC2 would be the second most important, and PC3 the third. So let's take a look at the output of the algorithm. This table describes how each category feeds into each PC. But to understand the results, let's just focus on one PC at a time. And just like before, we'll highlight the sign and the magnitude of each value. From this table, we can deduce that PC1 is a category that is defined by high linearity, low influenceability, high efficiency, and to a certain extent, somewhat speedy. That sounds a lot like aggro to me. And if you were to flip the values, the opposite sounds like control to me. So that means that in this game, aggro and control are opposite ends of the same axis. Now that's not some crazy insight, but that also means that our methodology makes sense to a certain extent. You feel that? The rush of making insights? Can't be beat. Also, if you want to have access to the data, or you want to help collaborate or gather data for future projects, feel free to join my Discord server, it's in the description. So let's see what this axis looks like. Now as a reminder, decks can lie anywhere on this axis. So for example, let's take a deck like Red Hybrid. I think it's pretty uncontroversial to say that Red Hybrid is a very aggro deck. So we'll put it on one end of the axis. Let's compare that to Security Control, which, as the name suggests, is control. Now remember when I was talking about importance? And how PC1 is more important than PC2 and PC2 is more important than PC3? Well, that's because now you can see that PC1 actually represents 33% of the original data. That means that just this axis alone represents 33% of all the 7 categories, meaning that the aggro control axis is the most important facet of a Digimon deck, or at least according to the way that I developed the categories. Now let's revisit the original table. We can now label PC1 as aggro, and now we're going to do the same thing as we did for PC1 to PC2. And since we've already done it once, we can do it again but faster. So just like before, let's highlight and emphasize the most important traits to PC2. It looks like these are decks that are primarily wide, sticky, have a lot of presence, and are efficient. And according to the data, decks like Jesmon, Numemon, and D-Brigade score highly in this category. What those decks have in common is that they get a lot of bodies on board really quickly. So I'm gonna decide that this label is swarminess. So all we have left to do is to plot it. Just like before, the decks can lie on the aggro axis, but now they can also lie on the swarminess axis at the same time. Let's take Numemon as an example. It's definitely known to be a deck that has high swarminess, and is definitely more on the aggro side, but I would still say that it is part control, whereas a deck like Leviamon definitely doesn't try to swarm the board, and is more on the control side. And going back to the importance metric from before, swarminess represents 30% of the original dataset. This means that we have 63% of the original dataset in just 2 axes. And as far as our use case is concerned, 63% is kind of enough, but let's see what happens if we add a third axis. Now going back to our PCA table, we now have swarminess as a label, which leaves us with PC3 as our final column. This column seems to be defined by low stickiness, high wideness, and is a little bit efficient and influenceable. So what could it represent? Decks that score highly in this category are decks such as Ragnar Lordmon and Machine Dramon. Decks that score lowly in this category are decks such as Bloom Lordmon and Fenrir Lugamon. Looking at this and the rest of the data, my assumption is that this represents robustness. Very similar to stickiness, but really focuses on having a single stack. And for a final time, let's plot it. Just like before, the point can be on the previous 2 axes and this new third one. Let's plot Ragnar Lordmon to start. And right before we plot it, let's start moving the camera so that you can see where it is in 3D space. Definitely a deck with high robustness, some aggro, and low swarminess. And let's compare that to Fenrir Lugamon, a deck with low robustness, high swarminess, and high aggro. And now let's look at how much of the original data is captured by robustness. By my calculations, robustness represents 15% of the original data. What you might see here is that there's a large drop-off in the original data that's being represented for every principal component that we add. The first one was 33, then 30, now 15. And because of this fall-off, I think it's safe to say that we've captured enough of the original data in our principal components. But what if we hadn't? We can see the weight of the 3 axes that we created. But what if we created a 4th one? Let's say a PC4. What would that look like? Well, just as a precaution, I actually made a 4th column. These decks are characterized by being efficient, non-linear, and narrow on the board. To me, that reads as toolboxiness, but as we get this far into the PCA process, things start to make less sense, especially with this little data. And just for the sake of completeness, let's see how this toolboxiness category represents the original data. And shocker, it represents only 6% of the original data. So pretty insignificant as far as our results are concerned. So now that we've done our due diligence, we can ignore PC4. So in conclusion, we've determined that the most important aspect for deck building in this game is first, how aggro is the deck, followed by how many bodies it puts on board, followed by how protected are those bodies. What'll be more interesting is that in the future we can see if any of these correlate with winning decks, or even just color in general. So if you're a data nerd like me and want to hear more about those projects, please stick around and subscribe. Until then, see you next time.